Okay, now that we've talked about how to draw free body diagram and also know how to calculate net force if I give you more than one force, we're now really moving on to this physics of it, which are the Newton's law. The Newton's law basically helps you explain why things are moving a certain way. So the lesson Newton's first law, it's asking you if you're assuming that there is no friction. Okay, so assuming no friction. What happened if I have a ball here and if I let go and drop the ball down the ramp? What do you think is going to happen? Okay, so the ball will probably move all the way over here and probably would come up to this point. It will not go past the same height and then it will go back down and keep going again. And theoretically, if there's no friction, I should be able to make it back to the first spot and keep going. How about if we move the ramp? Okay, if we move the ramp further and further down, you would notice that if this thing is going to keep going, same thing if it's at situation B, it's going to make up to the same spot again, and then it's going to come back down and keep going and come back down. And if I opened it up, I don't know, mine is cut off, but yours should look like this and go all the way straight. Theoretically, if there is no friction, the ball should keep going. And we call this motion inertia. Inertia means it's not going to change and it's going to keep going. And every object has this properties called inertia. Okay, inertia is the property of matter that causes an object to resist change. And it wants to stay into that same motion. And it's always proportional to the mass. So if I ask you a question, which inertia will be bigger, an elephant versus, say, I don't know, a cow, okay? If the mass is higher, inertia is higher. So it's going to want to keep the same. The higher the mass, the higher the inertia is. And so, this is what the Newton's first law is saying. They're saying that if the net force is 0, they tell you that the object will maintain its state of rest or constant velocity. If you remember from the beginning of class when we talked about whenever something is at rest or if the constant velocity, meaning if the velocity is not changing, we actually would say that the acceleration is 0. It's not changing the speed, it's staying the same. Okay, so the implication of it is if the object is remain at rest unless acted upon by a net force. So object maintain at rest unless there's some net force that is acting on it. Another implication of this, I'm going to move these guys. Another implication is that the object in motion will stay in motion unless there is a net force acting on it. And if the object is moving at a constant velocity, it's saying that the net force is 0. And finally, if the object is changing speed, there must be a net force. Okay, let's just draw some pictures here. Okay, so this is what first law is saying. I'm going to probably ask you to write this down. So kind of implication of the first law. If the question, somewhere in the question, they say that the object is traveling at a constant velocity, it's telling you that the acceleration is 0. The conclusion that you can draw from the first law, conclusion that you can draw is that you have a net force of 0. Okay, that would go into questions like something like this. If I tell you a car is traveling at a constant velocity, okay? This is something tricky. Even sometimes grade 12 university kids will get it off. If I tell you that there is a friction and an applied force, and force of gravity and force of normal, if I tell you that the FA is 10 Newton, if you truly understand Newton's first law, you would be able to tell me, oh, the car is traveling at a constant velocity, meaning the net force has to be 0. If the forward force is 10, the conclusion that I can draw is that this backward force also should have 10 newtons. Okay, and then vice versa. If I'm asking you, if I tell you that, oh, in the question, they're telling you that the net force is equals to 0, and I'm asking you what is the acceleration, then you can say, oh, according to the first law, if the net force is 0, the implication is the acceleration also has to be 0.